Hi everyone, welcome to my channel. Today I'm returning to the subject of the OpenID slash OAuth2 protocol, and I will be talking about tokens. Tokens are the basic things that you really have to understand in this protocol, because even if you don't understand all the flow, at the end of the day, your client or your application, your web application, your device or your machine will receive a token, and you should know what to extract from it and where to send it when it's necessary. And that will be the main subject of this presentation. So let's move on. First, let's remember what are the four main players. There are more, I'll show you in a moment, but there are the four big ones, which is the resource owner. It can be you, it can be me, end user that does a login in the system, a client application. That will be the application that will represent you. Remember that you use OAuth2 to generate a token, more than one token, but let's talk in this way. You generate a token to delegate to this client, as a person you want to delegate to the client some authorizations when accessing API or any other resource server, which is our third player. And of course, for the glue for all of these things is authorization server. That will be the most protected player here, because it will generate tokens, validate tokens, provide the login and password, provide in the sense that provides a login web page when a person needs to authenticate. So these are the four main players in any flow that we have in OAuth2 OpenID. There are other players that work behind the scenes. I will refer them here. I will provide some details in later slides, but for now, let's just go through them in a quick way. So you have the device client. If you remember the device flow, just remember that if you want to register your YouTube on your TV, that's the device flow. So you will not enter information in your TV. You will use a different device. That's the device client. Of course, machine client, when the user, it's a machine. When you want to imagine that you have a cron job and you need a machine A to connect to an API in a machine B, and so it's not a person, there will be no login, so the login will be replaced by a client ID and a client secret. For instance, you have also something called user info endpoint. When you are on OpenID and you generate an ID token, for instance, or even access token, you can use it also to validate, and you want to check, okay, is this information correct? I have this access token, can I accept it? For instance, the resource server can ask to the authorization server about the validity of a token that is receiving, for instance, from a React application, Angular application, and so on. You have also the introspection endpoint that lets a resource server validate opaque access token. It can be access token or any other token. An opaque, it's a kind of a property of a token, but sometimes it's also a token. And I'll explain in a moment the difference. For now, just think as opaque token is just an ID. So you don't have any attributes related with the token. So every time you need to know more about the token, you have to ask. And when you have to ask, you should go to authorization server. And the authorization server, usually they have an endpoint called introspection endpoint. If you are using JSON Web Tokens and you imagine that you are a backend and you receive an access token, you don't want to ask to the authorization server about the validity of that token. You just want to ask for the public key so you can use it to decrypt information or to validate that access token without sending the access token to authorization server. That's one of the usages of this JSON Web key set. And of course, identity provider, it's an external system that authorization server can delegate authentication to. I will not be talking in this video about this one, but these are scenarios when you have a federation in your company, you have multiple probably authorization servers working for different domains and things like that. So it's more complex, and usually it's called identity provider. So this is, I try to put in this image, and you can pause it. I will not tell what it is, this image, but I put it here because it resumes every flow that we talk about. So you have here the main player, the authorization server, you have the resource owner, you have the client application here, and you have the resource server here. But there are two other players that we talk about in other flows. One is the machine client. When you have a machine to machine, a machine that wants to connect to another machine and wants to authenticate, so there is no user. And you also have the device client, for instance, a TV, where you have your YouTube and you want to put your user inside that YouTube, but you will not insert your credentials on your TV. You will insert them on your mobile, for instance. So this, at the end of the day, we can see that you have 1, 2, 3, 4, 5, 6 players that work as a kind of components in the OpenID solution. When I say OpenID, I will use the OpenID / OAuth2. Sometimes they are the same. The OpenID is only relevant when you are interested in something called the ID token that you can see here, meaning that you want to get information about the user. You need an access token for your client to access APIs, but you also want to know about the user that authenticate. Maybe you want their photo, his address, contact, and things like that. And for that, you need an ID token that I will explain in a moment, each one of these. So this is a kind of a summary of all the tokens and how are they shared between the components. So you can see here, for instance, these are the endpoints inside, or the services that run inside authorization server. Think of it as a kind of a Google. So you have an authorization endpoint that will provide you a login and password. You have a token endpoint that will generate the tokens when you need. For the device, if you remember, or you can check a previous video of mine explaining the device flow, it is necessary, a kind of a service that the device pings every few seconds to check if the user already authenticated on a mobile or not. The introspection and the GWKs that I've talked before. So one for the public keys and the other to validate tokens, for instance. And of course, you have the research server. At the end of the day, you always need an access token to access the research server. You can see it here quite clearly. The research server needs an access token. But your research server, sometimes it can validate by itself when it receives access token. And you'll see in a moment how, because the access token already contains information there. But it can also try to get keys to help him to validate the token. So sometimes most of the research servers, they go to the authorization server, they download the public keys, because most of the things that you see happening here, they are signed or encrypted using a private key. That's why you can get the public key and do the reverse. And when the research server gets these keys or do the introspection if it needs, what will happen, it doesn't need to go every time to the authorization server, because it's a public key. There is no reason to go. The public key will not change unless it's revoked, and that. But for that, you will have to wait for the expiration time of the token. That's why it's a good idea to not give long periods of time to the tokens. So you can see that's why I created this diagram, so you can see and understand better what's happening. So in blue, you can see the access tokens. The ID token, it's this orange, and the other ones are just codes that are passing by between the components. So if you check all the flows, you can see they are all them. So this is just a way for you to understand the visual and all the components that are involved. You don't have to remind all this picture, but if you understand the flows, you can draw it yourself, because it should be logical what you have to do. So here I tried to just add some of the services that are inside authorization server that I didn't talk before in my previous videos. So what are tokens? So let's go into more detail. At the end of the day, it's a digital proof of permission. Remember that the token represents what you allow an application to access in a resource server. At the end of the day, it's that. So be careful where you store it, because if someone gets this token in their application, at least while it is valid, they can use it to access the same information. Okay. At the end of the day, that's what the token is, but we'll see more details about them. So that we can say that we have 4 token types. Now, you can say that all of them are tokens, but some of them are, let's say, are a mix of the tokens. So let's see in detail. So you have the access token, which grants access to protected resource. Mainly, if you remember, this is to access the resource server most of the time. Okay, now you have the ID token. The ID token is not a token that you will send to a resource server. You can see here that there is no ID token to the resource server. The ID token is deployed to a device client, it's deployed to a client, and that's it. Now it will be the responsibility of the client application or the device client, if you are using a device, to check what's inside this token and validate accordingly. Say, okay, I'm expecting this user and I'm expecting this authorization server, and that's what's inside. So I'll trust this token. You can ask more information to the authorization server, but usually it's not necessary. Okay, now you have the refresh, but at the end of the day, just verifies the user identity. The refresh token, it's a token to help the security that we apply to the access token. Usually on the access token, we say, okay, you are valid for 2 hours. For instance, why do we choose 2 hours or 1 hour or 24 hours? It depends on the context of the solution. But imagine that you are using a web application and you store an access token and it's a public place, or somehow you discover that someone is being able to steal these kind of tokens. So if you have a big experience time, a long experience time, you have to wait for this. It's very difficult for you to revoke because the resource server will trust this access token if it's valid. Will not ask every time to the authorization server to check if it's okay or not. So the idea of the refresh token is, okay, I will just give 1 hour to the access token, but after 1 hour, I will use this token, the refresh token, to get a new access token. And you can say, okay, but it's not the same thing. It's not, because the access token contains internal information. You will see in a moment that the refresh token doesn't, which means that if you have 1 hour here and someone steals the access token, and steals also, you can say, okay, but it can also steal the refresh token. But first, the refresh token doesn't have information, and you can go to the authorization server and you just remove it from there. You say, okay, this refresh token is no longer valid. Why? Because after 1 hour, the refresh token should be used, and when it will be used, it's not on the server anymore. So it will not be possible to refresh. It means that the attacker cannot get any new access tokens. That's the main idea of the refresh token. And we can say that the refresh token, it's also an opaque token that we'll see in a moment. And what is an opaque token? It's just a reference, like an ID. It's like you imagine that you have a card, like your identity card with several numbers and information about you, but you also have a kind of a small paper with just your ID. Okay, that ID will be your opaque token. So you get this ID, you go to a place, and you can get your card with all the information. So the opaque token is just an ID, like a primary key that you can use to get other information. And it's a good thing, because every time you need information, you have to get and provide the opaque token. And if you block it, there will be no security issue. So at the end of the day, the opaque token, it's more safe than the other ones, but it implies that you have to request all the time, every time, the information. And for instance, access token, you don't have to do that. So let's see more details about the access token. So it's your API to the kingdom. At the end of the day, all the flows target to get an access token, meaning you want to access a resource server from a client, from a device, from your application. So the purpose is to authorize request to resource server. It can be a JSON web token. I will talk in a moment about JSON web tokens, or it can be an opaque string also. But if it's an opaque string, you have always to ask to the authorization server. It seems a good thing, but if you think about thousands or hundreds of thousands, it's not a good idea. You want to mitigate this. Or if you are in an environment that once in a while there is no internet, that can be a problem if you need information that's inside the token. Okay, but usually can create, like, say, short-lived, like 10 minutes to just a few hours, and then use the refresh token to get more or new access tokens. When it is used, usually in the HTTP header, like this authorization bearer, and you put here the token. So this is the internals of an access token. you can see it should be simple for you to understand what is. So when you receive a token like this, and I have the explanations here below, it tells you, okay, what was the server that generated them, what was the user that started everything, what is the audience. This audience is quite important because it's a kind of a permission saying that this token can be handled by these servers, and it can be your backend servers to where you will be providing this token that can use it, for instance, to access a research server. Sometimes you have a backend and you have an API and to access the API. And you can say on the audience, okay, I have this server and this server can also use this token. Okay, then you have the expiration, when it was issued, the permissions for your client, which is the scope that we talked in previous videos, of course, identification of your client. And sometimes you can get this information. You can ask for different. It depends how it is configured on the server, like username and roles. It's not common sometimes to see the roles, but if they are, you can add them here to this access token. Usually when you do this, probably you won't be using the ID token, OpenID. I saw this when people want to, let's say, do authorization and authentication at the same time. So the user does a login and password, they receive an access token, and the application considers the user is authenticated. But you don't see here information about photos, address, and things like that. But at least you have the roles, you have the username, and you can do a lot of things with just these two types of information. So where do you want to use access tokens? In every application that needs to connect to the resource server. And that's it. There is nothing more to say about it. So now there is the ID token. The ID token is not used to access to anywhere. It just brings information about the user, and you want to, and you should validate information that you receive. Okay, because at the end of the day, it's just a web token. You can validate, you can, because it's signed, and you can, if you have the public key, you can check if there was a change or not, or a man in the middle attack. But at the end of the day, the purpose is to provide information about the authenticated user to the client application. Okay, you have additional information about the user. Usually it's short-lived, typical matching the access tokens lifespan. That's a good practice to do it. So when it's used, it's consumed and validated by the client application to establish the user session. It's when you want information about the user you want to put on your website of your application. Okay, it's not to access nothing. It's just to get information, but you want that information, for instance, to be reliable. It has one more function that I will explain in a moment. And the internals, it's very similar to the access token, but here you can see email, picture, preferred username, local, email verified, authentication time, and things like that. You can even add your own attributes here. The idea, you can even put audience here, but the main idea is just to have information about the user. Again, this is a JSON Web Token. You can validate and make sure that it was not provided to you wrongly or in a or falsified, let's say like that. So use cases for ID token: single sign-on, the user logs in once with an identity provider, let's say like Google, and other applications can trust the ID token to authenticate the user. So you can send this token to other applications in your architecture, and they can ask to the authorization center, is this valid or not? They can ask for the public key and make sure that the signature match or not this token. That's the main idea. And when we say that an application trusts this, it means it can create the user based on this. You don't have the password, but you can create a local password inclusive. So you receive this information when you connect, and you say, okay, this is the user that I have, so I'll create a local user. I will trust that this user exists, this email is valid, because if you check details, you can understand where to ask to validate this information. And this high SS, you can see it's the issuer of the token. It's the authorization. So you can always ask if this is valid or not. Okay. Client-side profile display, because you have information about the user, and as I was saying, user provisioning. So you can create automatically user based on this information. You can trust this information. If you don't trust it, again, you can always ask to the authorization server about refresh token. It's just, as said previously, it's a token used to obtain new access tokens, and it's mainly opaque, and I will explain in a moment what that means. So you can see here, this is the content of the refresh token. The token, it is just this ID. So you don't see here information about the audience, information about the client, information about the user. When I say information, the attributes of it. Of course, you have the token type, you have the client ID, user ID, and that's it. This is the only information that it's necessary. But you have to take all the time this token information and ask for something, because it's an opaque, and usually you want to ask for an access token, but you should always go to the authorization server. You always have to be online. And access token, for the access token, it's not necessary to be online while it is valid. Okay. Refresh token use case, of course, to maintain a user session. Background task, usually can use a background task, let's say, that goes every hour and check if the token, or maybe you can program a very good background task. Let's say, okay, I will schedule this renew in my cron to renew automatically the access token that I have, so I will not disrupt my application. Okay. And an application can continue to function in limited capacity and request a new access token once online, because the access token contains information that you need and it's valid, but the refresh token always needs online connection. And of course, the opaque token, which is called also an hidden identifier, and the purpose is a non-descriptive string, it's just an ID that acts as a reference to a token record on the authorization server. Imagine the table where you have this ID, which is the token, this opaque token, and now you have details about the person, about the access, or whatever it represents. And if you remove this line, the entity or the model or the component that was using this opaque token will stop working, cannot use it anymore. It's really safe. But of course, on the other side, since there are no information on the token, every time you need additional information, you have to ask to the authorization server. Okay. Usually, by the way, it's used by the resource server, must call the authorization service introspection endpoint to validate the token. That's one of the things, one of the purpose of this token. And when you send a kind of opaque token, a common response, imagine that this is the refresh token. Again, the opaque token, it's not a token per se. It's a type of token, and the refresh token or access token can be opaque tokens. But it's also somehow a token because it's just an ID that you can put in architecture. I have saw in the past some solutions in the architecture where we were integrating systems and we didn't want to share information, internal information of one. Let's say, imagine that it's between clouds, and the first cloud generates a kind of a token, and we want to share this token in the second cloud. And most of the time, we just send an opaque token, and every time the other cloud needs to know information, it should ask to our cloud about it. And now that's a good thing because I can accept or not this validation. That's one advantage. I can ask, okay, who are you? You have to authenticate first. Okay, do I accept your request or not? I don't. You have an opaque token, but I still don't accept you. That's one of the advantages of using an opaque token. But that's the main idea of the opaque token. And in this case, we are using it to generate an access token. So why go the opaque route? Why do I want it? For the examples that I did. But first, simplicity for the resource server. The resource server does need to implement JSON Webtoken signature validation logic. Remember that the access token can be a JSON Web Token, and I'll explain in a moment what that means. In that case, we just want a very simple resource server. It doesn't care about the token. Just every time it receives a token, just ask to the authorization server, okay, is this valid or not? It is, okay, so I can go ahead. I don't want to, if I want details, I ask for them. Maybe you can cache them, and at the end of the day, yes, somehow a kind of a, let's say, manual made access token, if we can say it something like that. Token revocation, it's better because since you remove the opaque token on the authorization server, there is no access again from any entity regarding that opaque token. Remember that opaque token is used all to every time you need to use the opaque token, there is a connection. If it's not there, there will be, of course, false and forbidden to be used. Okay, so it prevents unauthorized clients from inspecting the claims inside the token because there are no claims inside the token. It's just an ID. So let's talk a little bit about JSON Web Token format. If you already know, you can skip it. I will be fast so you understand. So JSON Web Token, it's a very popular format to provide information about tokens and tokens. It's a way for you to, let's say, encode attributes in a safe way. The idea is not to encrypt the data, it's to be there, but to make sure that the integrity remains, meaning that you cannot corrupt or change any of the attributes. Imagine that you have a system where you receive an access token. Now we change one of the properties and we send to another backend trying to, let's say, lead to wrong behavior on the backend. Or in other words, we try to hack it. And you'll see that it's impossible with the JSON Web Token. Why? First, the JSON Web Token just made of 3 parts, let's say in base 64. It means that you can decode it quite easily. And you have an header, which is a JSON, a payload, which is also a JSON, and a signet, which is the result of a signet that I'll explain in a moment what it is. And you have these dots here, and they really exist on the final product. So first you have the header, and if you think like an envelope, it's like you have a kind of address or meta information about what's inside. So usually we have 3 attributes. One is what is the algorithm used, okay, for the signature or to sign the token, so to make it incorruptible, let's say like that. The type of token, it's always JWT, of course, and you can also pass the key ID, use it to identify which key was used to sign the token when multiple keys are available, because when you sign, you need a key. Okay, if you are using a private public key, if you are using a secret token like a symmetric encryption, of course, you will not see any secret there, of course. So now you have the payload. This is the header. Remember the header. It's the first part. Now you have the payload. Payload. It's where the attributes that you see, for instance, on the access token or the ID token. You have the ICS, the sub, the audience, the expiry, when it was issued, the scope, and other attributes that you can put. You can put as many as you want. Okay, it's the payload. Okay, and then now you sign this, and usually what you do is just to you encode the header, you encode the payload with a point, and then you apply the algorithm to sign. Usually it's this hash. You use the hash 256. Okay, let's see how it works so you understand. So imagine that you have this header like this. This is the algorithm used for signing, and this is the type of token. You can see there is no secret here because we are not using public private keys. We are using simple secret. And this is our payload. You can put the attributes that we want here. The sub, the name, if it is admin or not, when it was issued, and so on and so on. Okay, so this is not an admin. Imagine it's a user, and we say it's not an admin. Now we encode to base 64, and it should look something like this. We do the same for the payload. So you will see that the final will be this first part, dot, then you have this second part here, and then we have the dot, which is the payload, and now you apply this algorithm. This algorithm, I'll not explain into many details about it, but at the end of the day, it's like as if you have the other. It's more than this for security reasons, but at the end of the day, you have a secret, you have a password, let's say like this, okay? And then you calculate the hash of this the header and the payload, but you apply the secret there. You concatenate the secret and you hash it, and it will return something like this. If you look into details, it's not just one hash. There are 2 hashes to avoid specific attacks, and it also uses something that is padding. It's about the size of the bytes, but at the end of the day, it's a regular signature, but as safe as possible. So it means that if you don't know the secret, if imagine that you have a secret that you concatenate to a string, okay, and then you hash it, okay, and then you put it, and this will be this one, just for a simple explanation. So if someone changes something here, okay, this hash, this code base 64 will be different. Which means that the receiver of this, when he gets these 2, and since it is the only one that knows the secret, and we apply the secret and hash, the hash will be different here because you change something on this code base 64. So I understand, from that point you start to understand that, okay, someone corrupted the data. Since the signature, this token, let's say, not token, it's a bad word here, it's not the right word, but this string here will be different when I apply it to these two. So I don't know what changed, but I know that something changed. So I will not trust this token. That's why the JSON Web token, it's protects against corruption. And that's quite nice because you have this string, and if you change it, you cannot in any way to make the server accept it, because you don't understand how to generate a correct string here, because you don't know the secret that will be concatenated to these two strings. Okay, that's the main idea of a signet. If you read the theory about signing documents, you will see that it's quite simple algorithm, but very effective. Its only weakness is, okay, both systems that share this information should know about the secret and should have protected as much as they can. If the secret is revealed, then it's everything goes away. So imagine that someone wants to tamper the JSON Web Token, so they want to change the admin to true. So this string here that was before, you can see this B9 and the rest, you can see now that it's different, which means, but you try to make the other system go wrong and say, okay, I just changed this, but of course I will not change this because that's the initial signature. But when the system that is receiving take these two informations, concatenate the secret, and calculates the hash will not be this one. So he understands that something changed here. He cannot guess it was this, because it was not the original one. But he guessed that something tampered the string. So it will not be trustable, which means you just stop. You don't use that token, and maybe you can ask for another one, and you do the same. Okay. This is usually the way it works. Imagine that it's a resource server that wants to validate the token, so it receives the header, concatenates with the dot, now the payload, and the secret, it's something that only the resource server knows and the authorization server, and then you recompute the signature, and if it's different from the provider signature, the token is rejected. Okay, so you can say, okay, so I have to put the secret that exists on the authorization server also on my resource servers. Yes and no. Yes, for the let's say demonstration purpose, but from the practical point of view, you don't want to do that. Maybe what we want is just to create a private key or certificate on the authorization server, and then you have public keys on the resource servers, and that should be enough. It's because public can be public. Okay, and now you can validate against authorization server. And where can you get the public keys? If we return to our draw here, you can have here the public keys. So fetch keys, no token, optional JSON Web Token verification. So it is this rule. So a resource server can connect to the authorization server. Give me your public key because I will be using it to validate the tokens using the signature algorithm. Okay, that's the idea. It's one more row for you to understand about that drawing. Okay. So what is the difference between JSON Web Tokens and Opaque tokens? I think you understand now JSON Web Tokens. First, the JSON Web Token is self-contained. It means that it contains all the information that is necessary. You don't need to send this token to the authorization server to validate it. You just use a refresh token for that, because all the information that is necessary during a specific time, it's valid. The Opaque token, the resource server calls authorization server to validate. Okay, for the revocation in the Opaque, it's quite simple, just remove it. Here, it's more difficult, or you have to wait. You can revocate on the server, but you have to wait for the expiration time. Okay, or the main idea, that's why you should give a short lifespan to the tokens that you generate. Okay, scalability, it scales better, the JSON Web Token, because you provide to multiple clients or multiple research servers, and there is no problem with it because they are self-contained. All the information that is necessary, it's there. The opaque, it can become a bottleneck if introspection calls are frequent. Imagine that you do a lot of calls to the research server and the research server doesn't, because it cannot cache it, the solution, because it's an opaque token and doesn't have any information. So it's always pinging the authorization server, asking for information. That's one of the disadvantages of the opaque server. Okay. From the client point of view, the client can read the payload because all the attributes are there. User email, not the password, the roles and all the attributes that are necessary are there. The client only sees a meaningless string like an ID. So how does it work? The opaque token in action, if you are a more visual person, so I have the research server, it calls an endpoint, usually called Introspect. It sends this information to the server. Of course, it should send the token, and then you'll receive, say if it's active or not. And if it's active, sometimes it provides additional information here that it's necessary for the research server. That's how it works behind the scenes, the opaque server. The opaque token. Okay. Use case: opaque tokens and revocation. A user account is compromised and their tokens need to be revoked immediately. JSON web token, the tokens will remain valid until they expire. That's a weakness. A separate revocation list would be needed. Of course, and I highlight this a lot. That's why you understand, and I hope you understand now. Probably you already knew about it, but now you understand better why you should put a very short lifespan on the access tokens that are JSON web tokens. An opaque token, okay, just authorization service simply deletes the token record from its database. And any introspection, meaning when someone calls introspect to this token, the authorization service, I don't know nothing about it. And that's it. So there will be no information provided to the client. So token storage, where to keep them, it depends of a lot of factors. This is just some ideas. Access tokens, store in memory. It's the best place because it's difficult to hack. Or a secure browser storage, like a session storage for their short duration. Avoid local storage due to cross-site scripting risks. Refresh tokens should be stored more securely because it's a token that you can use to get more right. Usually, if you put in a cookie, it should be HTTP only or a secure server-side storage, for instance, in a backend. Sometimes people do this pattern. So you authenticate in a client like Angular or React, but every time the sensitive information is stored on your backend, and so no one can access it. And when you need specific actions, critical ones, you call your backend, and the backend now will renew the token and will give to you. Of course, it's not as simple as that, but I see this pattern a lot in some implementations. Okay, token validation, the final step to security. Access token, the research server validates its signature, as we saw previously, and how to do it, or introspects if it's an opaque. It also checks for expiration and scopes. Of course, it's not if it's valid. You have also two things. Let's put it quite fast here so you remember that. On the access token, here you can see you have scope. These are the things that the resource server will allow the client to do. In this case, just to read profile and write post. And of course, you should check this expiration. After this, the backend should refuse to give response to any call using this token. Okay, I'm sure. And of course, ID token. This question was for access token. For ID token, the client validates the signature. You want to, as we saw, so we can validate the signature of the JSON web token. If it's valid, it means it can trust it was issued by that authorization server. It means that we can trust the issuer, the audience, the expiration to ensure it's a legitimate token for the application. And of course, you can trust the information about the user if everything else it's valid. Again, this is the diagram that I provided before. If you pause and look into it, maybe it should be clear. I hope it is clear for you now how these tokens work. So you understand now what is authorization endpoint, the login and password, the token endpoint that issues. So here it can have a secret, can have a public key to issue access tokens. It put the expiry, everything it's generated by this token. endpoint, if you want to validate when you have an opaque token, or you want to validate the signature of the JSON Web Token, for instance, from the research server, you use this one here. You can do the introspection here when you have, for instance, an opaque token. You can ask it here for information. This is for public, this is for the introspection. Device authorization is just a service to support the flow for devices. Remember, when you want to put your account in your YouTube's application inside your TV and you authenticate on your mobile, behind the scenes, the device client, if you remember, generates an ID, and this ID will be sent constantly to the device authorization endpoint here until you approve or not on your mobile application. So these are the main services on the authorization server. So if you want to implement one, which is a nice exercise, probably too very difficult to rival with the existing ones, but it can be a good exercise to do something like this. Okay, maybe I will do it in one of my architecture design series. So client application, machine client, device client, resource server, you should understand all of them now. These blue are for access tokens, the orange for ID token. Remember, the ID token, it's not to validate against nothing, it's just to introspect what's inside. You want to do a JSON Web Token verification if the signature is valid, so you can trust what's inside, which is information about the user, because you will take this information probably to create records on your application. So security best practice, it's always good to say. And so final checklist, always use HTTPS. That's, everyone knows about this. Validate all tokens. Sometimes I see people implementing, if you use a framework, probably it does it for you. But if you are doing it more manually, please validate it. And you already know what you want to validate. The scopes, the expiration time, and the signature. You should sign on your side and check if it's still the same string that is generated or not. Otherwise, don't trust it. That is as simple as that. There are really creative people trying to attack your system, believe me. So limit token scope, only request the permissions you need. On the scopes, you see a lot of read, only provide, it's the kind of a zero trust. Don't trust in nothing, don't give more than what is really necessary. Okay, implement token revocation, have a mechanism to invalidate tokens when a user logs out or their account is compromised. In web applications, this is crucial. And keep secrets secret. The secret key used to sign JSON Web Tokens should never be exposed, unless you use a kind of a public-private key. In that case, the private key will be on the authorization server that we expect to be really protected, and the public key can be shared with confidence. Okay, so in conclusion, token-based feature, some key takeaways. So tokens simplify and secure authentication and authorization because you delegate to them a kind of authorization to access a specific system. But of course, you have to enforce rules to make sure that these tokens cannot be corrupted. And that's why you use signature. And be careful what you put inside. Don't put sensible information inside a token. Even if it cannot be corrupted, it can be viewed. Remember that. Okay, scalable and flexible for modern distributed applications. That the main purpose of this protocol, the OpenID/OAuth2. I hope you understood all the token types that we talk about, at least the four ones. I said four, if you remember all of them, it means that you understood all of them. Correct usage leads to robust, secure application design. That's what you don't want your, as a conscience starts to ping you. You are not validating the token. You are not verifying the signature of the token. You don't want that in your mind, because people always think, okay, that will never happen until it happens, right? Tokens enable stateless cross-platform access control. Why? If you use JSON Web Tokens, you can see that you don't have to go all the time to the authorization server for validation, which is a good thing, but it means that you have a small span of time when your application can be attacked. So make sure that you cover all the bases regarding security and everything I talked during this presentation. So this is what I want to show you about the tokens. I hope it was useful for you. I hope you understand now better the OAuth2/OpenID protocol. I think this information with information that I already provide in my previous videos about this protocol and all the flows, I think now you are more capable of thinking about solutions using this protocol and how to apply them. And now you will not be surprised when you see the internals of a token. When you receive a token with all these 3-letter attributes, you should understand all of them and what happens in each one of the players in this protocol. So when you are designing application, let's say with a React, Angular, a backend, an authorization server, you should understand now what is the purpose of each one when they receive a token and what is the purpose of the token when reach each one of these components. So again, thank you for watching. I hope it was useful for you. Subscribe my channel. One thing, I will start to develop or create some splits of these videos. I know they are big, but I like to explain everything. I really like to people to understand, but I know sometimes people don't like to be 40 minutes watching a video. So I'll try to split it in parts in the future, but at the same time, I will always provide the complete, because if you really want to learn it, yeah, you have to see all of it. So thank you, and I hope to see you in my next video.